Hi guys, today I'm going to talk about the properties of quadrilaterals. So we know about a bunch of different quadrilaterals. So this particular quadrilateral is a parallelogram. We know that because it's got two pairs of parallel sides as indicated by the arrows. So these two single arrows indicate these two sides are parallel. The double arrows indicate that these two lines are parallel. Same as it's got two equal sides, so the single lines indicating the lines are the same length and the double lines indicating that those lines are the same length. Now a parallelogram is special because it can be cut into two equal triangles. If I cut along this diagonal, these two triangles are the same size. If I cut along the other diagonal, I'd have also two triangles that were the same size. Now a special case of a parallelogram is a rhombus. So a rhombus has two pairs of parallel lines still, but all of the sides are equal in length. And a rhombus is special because its diagonals also cuts it into two equal triangles, but they meet at a right angle. Okay, so we've got diagonals meeting at a right angle in a rhombus. What I haven't said that a rhombus is actually a parallelogram, just a special case. All right, another special case of a parallelogram is a rectangle. So I still have two pairs of parallel sides and two pairs of equal lengths, but a rectangle is different and special because all of the angles are right angles. But like the rhombus was a parallelogram, it fits all of these rules. A rectangle is still a special kind of parallelogram. All right. Now there's a very special shape that is both a rectangle and a rhombus, and you might know what it is already. And that is a square. So we know a square in that all the sides are the same length, but it also has two pairs of parallel sides, and its angles are all 90 degrees, so it is a rectangle, and it's also a rhombus. It's not true to say that all rectangles are squares though, or all rhombuses are squares. Okay. Now we didn't talk about special features of the rectangle. Now we talked about in a parallelogram how the diagonal cuts it into two equal triangles, but these diagonals are not equal in length. For a rectangle, the diagonals are the same length. And if you cut along this diagonal, you actually get the same two triangles as if you cut along that diagonal. And that's true in a square as well. Okay, another quadrilateral which we've studied is the trapezium or trapezoid. So that's defined by only having one pair of parallel sides. So if it had two pairs, then it would be a parallelogram, but it's got one pair of parallel sides, is a trapezium. And the other kind of quadrilateral which we study is a kite, not to be confused with a diamond, which is actually just a rhombus, really. But a kite has two pairs of equal sides and they're touching each other. It's got no pairs of parallel lines. So we see that these two lengths are equal and those two lengths are equal. And I can split that into two equal triangles if I cut down the long diagonal, but if I cut this way, then they're not equal. And those are the properties of quadrilaterals.